Hello everybody, I'm Alexey Krobro, the organizer of SF Scala. Here we're on location at Land Up, and for the first time with us we have Grzegorz who was one of the compiler team members at Typesafe, now Lightbend, right? So he's a Scala C guy, now he's at Stripe. He works on developer tools.
Yes.
And he's going to talk today about the notorious Scala compilation efficiency, right? So can you tell us a little bit, you have a very interesting medium, I highly recommend everybody read this, it's very interesting. It's about technology and life moving to San Francisco. Can you tell us a little bit, like how you went to Typesafe, how did you end up working on the compiler, what did you do after that, and how did you end up at Stripe?
Yeah. Hi, I'm Grzegorz. So where do I start? I guess I have a pretty unusual background overall, and kind of the story. It's my second time living in San Francisco, but going back to the beginning, I ended up first at EPFL before even Lightbend existed as a company. Kind of the story goes is that I was a bored Java programmer. I discovered Scala on the internet by accident. I started working on some projects, and then I was so kind of enthusiastic about it that I kind of demanded from Google that I will go for an internship with them only under the condition that I will be doing a project in Scala.
Wow.
Which was a very, the recruiter at the time, she was like, that's a difficult, difficult case, because they don't, at the time they were not doing Scala.
And I don't think they were doing much of it. Was Josh Sharef there at the time?
No, not at the time. It was way back in the day, in 2009. But finally she found one guy named Alex Spoon.
Yes.
You might, some people might recognize him from the book that Martin co-wrote with Bill Venners,
yes.
and Alex Spoon was he's the third person on that,
right?
On the cover, and he was basically the only engineer at Google that would be interested in doing a project in Scala. So I went there to Atlanta. I enjoyed myself over there for a summer. Went back home to Warsaw, and I think Martin and Lex were talking to each other and connected me to Martin. I actually didn't even when I got the email, it was so far-fetched idea that I would join the team working on Scala. It just felt like impossible dream. But I got an offer to come and visit EPFL, and eventually that turned into a master thesis program, and and kind of the story continued. And when Martin decided to bootstrap the company, I joined. That was during the time I graduated.
This is a great story, because now I have the final confirmation on video that Lex Spoon exists, because he's the only person we've never hosted him at our conferences. Right? Bill Venners is a local guy who gives excellent talks, and Martin keynotes Scale by the Bay. By the way, he comes back to keynote the Scale by the Bay 2018 at Twitter, which will be his first time. So we have two co-authors of the Staircase book. We haven't seen Lex Spoon. If Lex, if you hear us, if you see it, please come and give us a talk, or we'll come to Atlanta, because we really need to collect all the authors of the Staircase book, right? So that's very important. What did you do with Lex at Google?
I work on Scala GWT project, the Google Web Toolkit project. So the idea was to replace the Java backend with Scala frontend, Scala frontend with Java frontend with Scala frontend. So you would write Scala code and compile it to JavaScript. It was a fun project for summer, and it was also very useful for me to understand how to not build Scala to JavaScript compiler. and that was the biggest contribution I made at TPFL. Is gave the talk, and it was clear to everybody that that's not the way to do it.
So the negative result is also a result.
Yeah,
right?
I think that was very good negative result, and I got to learn a ton about the compiler.
So how then did it proceed? So you joined the team at EPFL. Did you move to Switzerland for this?
Yes, I moved to Lausanne. And at the time, I was actually very skeptical of moving to Switzerland because I deeply believed in America.
Yes.
I was like, that's where I want to go. And Switzerland I only knew it like as a country of expensive watches, which I wasn't really interested in, and cows.
Yes.
Like roaming freely in mountains.
And chocolate.
And Google Blocks. But like somehow I didn't associate in my head. I was pretty ignorant actually, looking back, that it's a very like strong country in research and in academia. So yeah, I went there, moved there, and kind of like after 2 weeks I realized, oh, I got like won a lottery ticket. And kind of then I realized that it was really good that I didn't reject that offer to move.
And how long did you stay at EPFL?
That was a year, 2 semesters. That's when I did a bit of research and kind of that resulted in master thesis.
So what was the state of the Scala C when you started working on this?
What was the state of Scala?
Yeah. How did you find it? How did you leave it? You know, like.
Well, so when I was at EPFL, I didn't work directly on Scala C. So kind of like when I was doing the internship with Lex, I was very involved in the kind of the compiler work. Then I switched gears to more of a researchy topics on lightweight modular staging. So that's what I worked on, and I was kind of a little bit removed from kind of the state of Scala C. Only when I joined Typesafe, kind of that was my main concern.
Okay. So you work. So you joined the Scala C team as a part of Typesafe.
Yes.
Yes.
Then I can like talk about like what.
Okay. And Typesafe. So tell us, how did you proceed from? So EPFL is a research setting, and right, you worked on Scala as a research project.
Yes.
Which kind of reflects its history because it started as a research project, and then you went to Typesafe, which like it's industry story, right? Like it's.
Yeah, like kind of transition from research, from academia to industry, yes.
Right. How was that? Like, did you want to go to industry? Did you have enough research? That's kind of...
No, I really wanted to do that startup, and it was a startup that like showed up in front of me, and I was like, and I loved working in a programming language. So kind of the idea that I can continue working in a programming language and have an experience of a startup at the time kind of sounded great, and also the people, it was clear that we would have to build San Francisco office, and I wanted to move here. So it was like everything is kind of like pointing in the right direction.
Right.
Yeah, that was the reason why I joined.
So was it when Paul Phillips started contributing, did you see, because Heather Miller, who was there then, she told me, I think at one of the talks at the Scala, that the team had to kind of build a special UI to review all the patches which Paul started sending. Like suddenly this source appeared, right? Yes. Did you see that happening?
So I joined when Paul was pretty established already. So I don't think I've seen the transition of like, oh my God, we're like, you know, a group of people who fit in the same room and like kind of know each other, and they're like this stranger from the internet, that you know starts sending a lot of patches. So I think at the time, by the time I joined, they kind of like already assimilated that idea that people will be sending patches.
And he moved the project to Git, right?
That was the move to Git. I'm trying to recall. I was involved in that, but. Whether that was a Typesafe or EPFL, I can't remember. I think it was at EPFL. It was many people were working this. Adrian Morris was working on it. I knew Git really well from my previous internship at Google, the other one, not with Lex. So I knew like Git internals really well. So we kind of like I helped with that. And yeah, it was just a lot of people involved in the process, and Paul for sure as well. Kind of like what would be the final state and shape. He had strong opinions on that.
Yes, as usual, which is great. Like we love Paul. He also is a regular speaker. So cool. So I mean, this is not for the faint of heart. Compilers, right? Compilers are really the most complicated pieces of machinery. How do you, I mean, dare to work on a compiler? Like it requires bravery, right? Like most people look at it. Now you can look at open source code of the compilers.
Yeah.
I don't know how many people stay there, right? Because obviously everything depends on everything else, and then it takes like years. So how do you approach it? Do you how do you internalize it? Do you look at the whole code? Do you stay like tunnel vision, what I need to do for today, for next hour? How do you deal with this code base?
So my approach changed over the years. Like at the beginning I was very confused, and Lex was extremely helpful because he's a good teacher, and I had like one-on-one interaction with him for first couple of weeks, like every day. And he was also very patient. Like I kind of looking back, I was very naive and I didn't have like formal training before I came for the internship. So I approached it as any other like software project. I used to do quite a lot of hacking on Apache Software Foundation projects, like some of the Java ones, and kind of there was a complexity cliff, compared to like regular Java programming, and then you go and hack on the compiler. It's just such a big gap that kind of like jumping in and figuring it out without theory is very difficult. So you need some basic understanding, and then at some point you build a model. There's this typical split between front end, which does more of type checking, and back end, which kind of translates to the low level target like bytecode. And these two are pretty separate, so you can focus at least your attention, at half of the compiler, and then you kind of drill down to whatever you're interested in.
Interesting. So, and I can have to like warn you that like this interview can go on forever, but we're a local guy, so I'll kind of scope it for now. We're not going to stripe things because we'll leave it for the next talk, right? But I would kind of end with kind of a general question. So we're going to have your talk about the compilation speed, but I think this is exciting times in Scala community because we have so many different things. We have Scala.js, we have Scala native, we have reasonable Scala at Twitter, which Eugene Burmako is working on. And going to present at some point when they have significant progress. And we have Graal at Twitter, which also it supports better speed for Scala. So Scala kind of is really going places. But obviously we have things like Rust, which are eating into the microservices stack.
Yes.
We have Swift. Right, and so we have kind of Kotlin, so we have a whole bunch of different things going on, right? And kind of Scala complexity and its slow speed of compilation is often counted against it. I personally, I never understood this because I programmed in Fortran originally when you get one shot a day because you write punch cards. So the compilation speed doesn't matter. Like you write code correctly, right, and it compiles, right? And and obviously Scala is complex and people think. So I never like it's not Ruby. You don't program it by typing and seeing that it's not like squiggly line under that, right? Like this is not normal. I mean, so my kind of one question is first of all, why is it such an important question? Because I personally, again, it's not like I don't think this is an important question. It's reasonable. Like it compiles within a minute. It's fine, right? Like it's. I mean, again, but then maybe for large teams and large code bases, important, right? So, but also, because you're kind of addressing very important ecosystem question. What is exciting for you? Like how this kind of going to help with a larger picture of adoption of Scala?
So I have two answers. One is. Compilation speed is kind of my personal preference in terms of like what I can contribute. And I actually in the talk I'm gonna kind of give a reference to specific inspiration I have of Brett Victor, who is a UX designer and very provocative person in terms of like how he sees the vision of programming. And I personally, I always loved like very interactive way of programming. And to me, kind of the dream, the pipe dream is that you have the experience of dynamically typed language in terms of like interactivity without the safety of compiled languages. That's what I'm like personally driven buy as a long-term vision. That's one thing, and I think you just build a whole new set of tools if you have a quick turnaround for the compiler. Kind of in the data science world,
yes,
people expect that you change the code and the plot is there in like 10 milliseconds or 100 milliseconds. And if the compiler takes 2 seconds to compile, like you just break that cycle.
Yes.
So then they end up using other programming languages, and it's pretty detrimental to like Scala's kind of overall ecosystem. So data science is one place where I would see.
And now I see a connection with Stripe. And now I see a connection with Stripe. Yes. But then we'll explore it later.
Yes, and they're completely random and unrelated to compilation speed, which is like what's coming up next for me in terms of interests. I think we're in the golden age. We are at the beginning of the golden age of new computer architecture, and this is driven by machine learning and kind of like the demand for compute. And Scala is almost well prepared, but not quite there to be like kind of the language that leads the pack. If like in like how do you do machine learning, this next generation machine learning, and kind of a new computer architectures, which will require big redesign of the compiler. So it's kind of orthogonal to the speed, but like you will have to redesign the compiler for that
and make it parallel and more efficient. Yeah, no, this is maybe a good moment. I want to unveil our own local/global initiative, right? So the 2019 is going to be the 15th anniversary of Scala, and so what I proposed to Martin, and he liked this idea, and EPFL team. Let's call it not the 15th. 15 years of Scala, let's call it 30 years of Scala, because we count 15 past years and 15 future years. And so this is inspired by the 50th anniversary of computing. It was celebrated by ACM, Association for Computing Machinery. So ENIAC is at the University of Pennsylvania, which is under my old office when I was a grad student there. So when the 50th anniversary was celebrated, Al Gore, the inventor of the internet, came and he turned on the ENIAC, and it counted to 100. So they celebrated 100 years of computing, right? So I really like your vision, right? Let's kind of start kind of putting down the themes. What are going to be the next 15 years, right? So because if we have compilation speed, then we can achieve, data science supremacy and machine learning and everything else, right? So really, I think, that's why this talk is really interesting, right, for the community, because it's kind of what are the foundations of improvement in the compiler. So thank you for working on that. Really appreciate it, and looking forward to your talk.
All right, thank you.
Thank you. And more